Had you already gone to the Easter break or what? Huh? Right. The first thing, the first thing I'd like to mention is that I think most of you did not get the right answer for quiz 9. I really don't understand why, because I thought I gave you guys a hint. The hint I gave you, you have a variable x. No. You're late, ma'am. You have a variable x which has this distribution. So that means the probability mass function is to choose x. Oh shit, what did I do? Is to choose x right? And this is the probability mass function, and there are only 3 possible values for x. X can either be 0, 1, or 2. And you are told there are n0 Yeah, this is what you're told. Now, first thing you should do, you guys okay what? The first thing you should do is to write down the likelihood. Now, what you have here is the probability that a single x is equal to 0, right? So we know that the probability that a single x equal to 0, if you put x equal to 0 into this, you get 1 minus p squared. And the probability that a single x equal to 1 is 2p times 1 minus p. And the probability that a single x equal to 2 is p squared. Right? But we don't have one single x, but we have like n0 observations, each equal to 0. So what's the probability of that? It's a bit like asking this. Okay, let me return to probability 1. I know you guys did probability 1. Right? If you toss a coin and you result in head, what's the probability of that? It's half. Right? Now, if you toss a coin 2 times and you get two heads, then the probability is quarter, which is half squared. And if you toss a coin 3 times and you get 3 heads, the probability is 1/8, which is half cube, and so on. Right? I mean, it's the same kind of question I'm asking you. This is the probability that a single x is equal to 0. But you have n0 observations taking x equal to 0. So the probability of that the probability of right, is 1 minus p squared to the power n0. Do you see what I'm saying? I mean, the argument is parallel to the coin tossing experiment, right? When you toss a coin once, the probability of head is half. Twice is half squared. Thrice is half cube, and so on. Okay? So, and similarly, the probability of n1 observations taking x equal to 1 is this, right? And similarly, the probability that n2 observations taking x equal to 2 is p squared power n2. All right? So these are the probabilities, and therefore the likelihood function is the product of these three. And unfortunately, most of you couldn't get this right. I mean, and therefore your answers were not correct. Okay? So this is the likelihood function for the data. And once you know the likelihood function, you know how to find the MLE, right? I mean, it's pretty straightforward. I don't need to tell you, because I did many examples on trying to derive the MLE given the likelihood, right? Okay, guys, is there any questions on this, guys? Yes? Yes? Okay. All right. I'm a little bit sick today, that's why I'm sitting down. I hope you forgive me. I'm not feeling well, although I will mark all your quiz 9s before midnight. I will mark all of your quiz 9s before midnight, and I will send it to you by email before midnight. Okay? Okay. All right. Now, the topic I'm going to talk about today, or maybe I should say, this is week 10, right? Week 10, we will talk about test of hypothesis. Week 11 is the week after the Easter break. We will also talk about test of hypothesis. And week 12 is the final week. It's the revision week. It's the revision for exam. Okay. All right, this is the plan for the rest of the semester, right? Okay, so today I'm going to talk about test of hypothesis, right? Test of hypothesis. Okay. So the first thing, I mean, I know some of you might have done this in other courses you have taken. Test of hypothesis involves a few things, right? The first thing is something known as the null hypothesis. and is denoted by H, capital H sub 0, right? That's the notation. That's the notation people use to denote a null hypothesis. This is usually the hypothesis to be tested, right? So for example, one example of a null hypothesis is as follows. Okay, so one example of a null hypothesis is this: the average weight of men is equal to 70 kg, right? Okay, and the second one, the second element is known as the alternative hypothesis. And is denoted by capital H sub 1, and this is sometimes known as the research hypothesis. Right? So for example, an example of a alternative hypothesis could be the following: that the average right, it could be that the average weight of men is less than 70 kg, right? That's an example of a alternative hypothesis, right? Or it could also be greater than 70 kg. That's another example of a alternative hypothesis, right? Now there's something called there are three kinds of hypotheses, right? One is called the two-sided hypothesis. Sorry, excuse me. Oh, I won't go into that yet. All right, let me go to the next topic, which is the test statistic. Test the test statistics is usually denoted by the following notation. Is right. So a test statistic is a function of the data. So I use the notation capital T in open brackets the data x1 to xn, right? The next one is the rejection rule. The rejection rule involves the test statistics. So usually it takes one of the following forms. It takes one of the forms either right, or right. So the rejection rule takes one of the forms. Either the test statistic is greater than some fixed number k, or less than some fixed number k, right? So this rule decides whether to reject or accept the null hypothesis. So the rejection rule applies only to the rejection rule applies to reject the null hypothesis. So if one of these rules holds, then you will reject the null hypothesis, right? And one final thing is, well, maybe I have more than one. Rejection region. A rejection region is where you right? So in other words, it's a set of all data points in S. S is the sample space. So by the way, okay, let me use a different color. S is sample space. Okay. So it's a set of all data in the sample space such that the rejection rule holds. Right? That's known as the rejection region. And the acceptance region is just the complement of that. The acceptance region regions is a set of all data points in the sample space S such that the rejection rule does not hold. Okay. Okay, so these are the things I have listed are kind of fundamental to any test of hypothesis. So just to repeat, the null hypothesis is the hypothesis that you are testing. The alternative hypothesis is like a research hypothesis. And then the test statistic is a function of the data that is used to determine whether H0 or H1 is true. And the rejection rule takes one of these forms, where k is a fixed number, right? And it applies to the null hypothesis. So if one of these inequalities holds, then you reject the null hypothesis, right? And this is the rejection region, and this is the acceptance region, right? The next thing I'm going to talk about is I'm going to draw a picture. I'm going to draw a big picture. Give me some time. I may get this wrong. Sorry, guys. Give me. So, right. As you know, I'm rubbish in drawing pictures. Do you see what I'm trying to do? Okay. All right, so this is the picture. Now, the decision of a test of hypothesis can be one of two outcomes. The outcome could be that you reject the null hypothesis or you accept the null hypothesis. All right, it could be one of the two. So that's what I have listed. You either reject H0 or you accept H0. That's on the horizontal axis. Now, on the vertical axis, maybe you can see this better. This is state of nature. State of nature is, I mean, we have no control over it. Only the God knows what happens, right? The state of nature can be one of two things, right? Either H0 is false, yeah, or H0 is true. You follow what I'm saying? Yeah? But we have no control over the state of nature because we are only human, right? We don't know what the state of nature is. Yeah? So there are four things that can happen, either this, or this. Now let me ask you. Now if you reject the null hypothesis when H0 is true, you are making an error. Right? And if you accept the null hypothesis when H0 is true, you are making the right decision, right? And if you reject H0 when H0 is false, you are making the right decision, right? And if you accept the null hypothesis when H0 is false, you are making the wrong decision. Do you follow this? Do you see this picture or no? I mean, it's a picture with 4 possible outcomes, right? 2 of the outcomes are wrong, and the 2 remaining outcomes are correct, right? Are the correct thing to do, okay? Okay, now, this outcome, that is the probability of rejecting H0 when it is true, this is known as, this error is known as the type 1 error. All right, and this error is known as the type 2 error, right? Right, so the type 1 error is the probability of rejecting H0 when H0 is true. And type 2 error is the probability of accepting H0 when H0 is false. All right, so let me write them down. Right? Right? So these 2 errors are unavoidable, right? So it doesn't matter how clever you are. I mean, you could be a Nobel scientist, you could be the Nobel Prize winner. It is impossible to devise a test that has 0 probability of type 1 error and type 2 error, right? Okay? So these type 1 and type 2 errors are bound to be there for any kind of test of hypothesis. But what we try to do in statistics is we try to right, we try to minimize the probabilities that of type 1 and type 2 errors occurring. Okay, that's what we try to do, because it's, as I said, it's impossible to eliminate. It's impossible to eliminate type 1 and type 2 errors from occurring. Okay. Okay. All right. Now, there's some more notation I need to talk about. Where am I? Oh. All right, some more notation. The first one is alpha is used to denote the probability of type 1 error. Right, and beta is used to denote the probability of type 2 error. Okay, and alpha is also known as the significance level. Alpha is also known as the significance level of the test, right? Okay. All right, guys, you with me? So these are some notation you will need to know, right? Now, I'm going to talk about one sample test. One. All right, the first test I'm going to talk about is testing for population mean when the variance is known. So I will suppose that you have a random sample from a normal distribution. Mu is the population mean, sigma squared is the population variance, right? Okay, and we are assuming that the population variance is known, right? Okay. So I'm gonna show you some test of hypothesis, right? The first one, this is the first one. Yeah. The second one, this is the second one. And the third one, all right, this is the third one. All right, so these are three different possible tests. So here you're testing that the population mean is mu0, which is a fixed constant, versus the alternative that mu is not equal to mu0. Here you're testing that the population mean is equal to a fixed constant versus mu greater than that constant. And here is mu less than that constant, right? Now, the rejection rule is as follows. For this one, you reject H0 if you reject H0 if this is true. So this is you remember I told you a few minutes ago, right, that the rejection rule takes a form of an inequality, right? And in this case, the inequality is of this form, right? That is, if this guy here, root of n divided by sigma times the absolute value of the difference is greater than this guy, you know how to read this, yeah? Then you will reject the null hypothesis, right? And for this guy here, this is the rejection rule, right? And finally, for this guy, right? This is the rejection rule, right? Now you may ask me how I came up with this rejection rules, and this is something that we will not learn about in this course. But when you go into year 2 or year 3, I guess, you will learn how to actually construct these rules for rejecting null hypothesis, right? I know it's a long way. It's a long way away, so you don't need to worry about it now. Okay, so this is, you guys okay now? Yes? Any questions so far? No? Yeah, all right. Now, by the way, about the R coursework, which is due 29th of April, if you need any help, if you are stuck on it, right, and you need some help, you can come to my room or you can Zoom me. I mean, I have already received several Zoom requests, so I talked to I guess I talked to several of you already by Zoom, trying to help you guys with the R coursework. So if you're stuck for some reason with the R coursework, please feel free to Zoom me, all right? Okay, that's what I'm saying, all right? Okay. All right, next. All right, number 2, we're going to talk about tests about the population mean when the population variance is unknown, right? Okay, so we are supposing that the data are from IID normal, but this time we are supposing that the variance is unknown. Okay. So in this case, the tests are as follows. This is known as a two-sided hypothesis. And both these are one-sided because the alternative hypothesis is to the one side only. Okay. Okay, guys. Now, in this case, for the first, you reject the null hypothesis. All right? You reject the null hypothesis if this is true. In other words, root of n by s. Remember, s is the sample standard deviation. I showed you how to compute it. I gave a formula a long time ago, unless you forgot it. Right? S is the sample standard deviation multiplied by this is greater than the percentile of the t distribution. Once again, I showed you how to compute this. I gave you copies of the t table. That is, if you came to my example classes, you would have noticed that. I'm not sure about the other example classes, which are not run by me. But if you had come to my example classes, I would have shown you how to compute, how to read values of this, right, from the table. Yeah. Okay. Now, in this case, okay, this is the rejection rule, and for this one, the rejection rule is right. And once again, I want to write down what your S is in case you forget, in case you start complaining that you don't know what S is. S is the sample standard deviation, is defined as this. Right? Okay, guys, so these are the rules. These are the rules for rejecting when you have a random sample from a population with the variance unknown. Okay? All right. Next. The next one is this. Number 3. All right, here now we want to test for population standard deviation, right? So suppose Right? Suppose you have a random sample from a normal population, right? And we want to test for not the population mean, but for the population standard deviation, right? So it will be like this. All right, once again, there are three sets of hypotheses. The first one is two-sided, and the other two are one-sided, right? All right, in this case, you reject H0, right, if right? So you reject the null hypothesis if either of these two conditions is true, right? So here S squared is the sample variance, sigma 0 squared is the value specified by the null hypothesis, and these two things are the things that you read from the chi-square table. And once again, if you came to my example classes last week, you would have known how to read these two, right? I mean, I gave you tables for these two in the last week example class, right? Right, this is the rejection rule for the second hypothesis. And finally, for the third hypothesis, the rejection rule is right. You guys okay? Any questions so far, guys? Right, now before you leave, guys, last weekend I sent you guys, or was it last week? Last week I sent you guys an email about teaching awards. I know I've been trying to support you as much as I can. I mean, as I said many times before, there's no one at the university who does the amount of support I give you week by week. So I would really appreciate if you could nominate me for those awards I gave you. I would be most grateful. Okay, thank you. All right, guys, see you. Any questions, come and see me. Hello.
My p-values are like 10 to the minus 14, but the d value next to it seems like reasonable. So I'm just wondering if
What distributions are you testing?
well, I tried normal and T, students T.
Yeah, you need to try Laplace, and you need to try scale T.
Okay.
Yeah, if you look at the scan notes for last Thursday,
Yeah.
you will see the distributions you need to try.
Okay, I'll
Yeah.
try it for class and
It's Laplace and scale T, or logistic. You can also try logistic.
and like when I tried them before, it said you need a starting value.
Yeah, you can choose it arbitrarily.
Okay.
Arbitrarily, yeah. Starting value, yeah. Oh, you guys are late every time. You're right, man. I need to go market. Can you see me tomorrow? Yeah. Anytime. I'll be in from 11 to 6. Okay. Or if you don't want to come, you can Zoom in from home or wherever. Yeah. Sorry.
Reading after we talk today, is this the Kolmogorov-Smirnov test? Is this a one sample test or a two sample test?
Normally it's two sample. It really doesn't matter. I mean, it's a two sample test. Yeah. Well, it's a. In this case, it's a one sample test. It's a one sample. Yeah.
Okay, because there was information about one sample and two sample, I didn't know which one to read about.
Yeah. It doesn't matter. You just use the command KS test that performs the one sample test.
Yeah. The syntax is different. So I'm going to choose the one sample test.
Yeah, all right. If you have difficulties, just Zoom me, man, anytime, 24/7. And this guy, he is Zoom me all weekend.
I wanted to ask about this. If we test, like, why did we not say anything about H1, about alternative hypotheses?
Yeah. The alternative hypothesis is this.
Yes.
And you reject the null hypothesis if this is true, right?
If these both true?
It depends. Sorry?
Do they have to be both true?
No, you only reject one of them. I mean, you can't reject both. You can only reject. Okay, if you reject H0, then you have to accept H1.
Oh.
Yeah.
Oh, okay.
You reject only one of them. You know what I'm saying?
Because I thought that we wrote it to be equal, to be less. So
Yeah.
I didn't think that they contradict each other.
Yeah, they will contradict. So if this
In
is
this
not
case,
true,
yes.
yeah, they will contradict each
Okay.
other. They will.
Okay.
Yeah. Hello.